Okay. Now, if y1, y2 up to yn, they are independent random variable, and they have what I'm trying to say now. Y1 has this as a moment generating function. Y2 has this as a moment generating function. Okay. If I have a random variable, that, then what is a moment generating function? I remember in this class, okay, if y1, if for y1, the moment generating function is this. For y2, the moment generating function is this. Blah, 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 until we get to yn, the moment generating function is this. But right now, we want to define a new variable, which is a function of this. And what do I want to do now? I want to find the moment generating function of that. And this guy here, u, is summation y, because this guy is summation yi, I start from 1 to n. Okay, so of t. Okay, now don't forget, recall that my of t is expectation of this. Okay, now here, okay, I'm actually going to have this raised to power t, okay, y1 plus y2 dot 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 until I get to yn. Okay, and here I'm going to have, I can rewrite that as exponential raised to power t y1, exponential raised to power t y2 dot 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 until I get to exponential raised to power t yn. Okay, and if you take a look at this, this is my of t multiply my1 of t my2 of t dot 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 until I get to myn of t. Okay, now if you take a look, that is what you're saying here. Okay, the moment generating function of the sum of a random variable is the product of the respective moment generating function. So that is what that guy actually means. Now, what I'm trying to say in essence, if I know the moment generating function of y1, y2 up to yn, and u is a function of this, okay, and this is a relationship, okay, I can get the moment, if I get the moment generating function of u, okay, which is going to be the product of this. After getting this moment generating function of u, do you know I can look at that moment generating function and be able to say this is a moment generating function of a particular distribution that I know. You know, it's just like maybe somebody was mentioning Minneapolis, St. Paul, Twin City, okay, and I want to guess the state in America, and I'm going to say, oh, that should be Minnesota. Okay, so it's like the moment generating function can serve as a pointer to a particular probability distribution. Does that make sense? Just like what I did, the one I gave in assignment, where you were able to figure how that to be a moment generating function for binomial. Does that make sense? Okay. Now, that is what I have here. Now, continue that. Do you know that if y1 up to yn are independently normally distributed, where expected value of y1, yi equal to that, what I mean here is expected value of y1 equal mu1, expected value of y2 equal mu2. Each of these random variables have their own means, and they also have their own variances. Covariance is 0, because they told us they are independent. Okay, now, and I want to talk about u, which is a new variable. But this very u, if you take a look at the u here, constant here is 1111 for all of these. We can have a situation, if you take a look at this now, where, you see that, where they have constant, the constant is A1, A2, up to AN. Okay, we can also have a new variable that's going to be a functions of old variables, and we're also going to have a constant along with that. Now, if I want to get the distribution for you, but let me tell you this: we've been told individually they follow normal distribution. If a random variable follow, if a component, okay, the component in the system follow normal distribution, then the whole system follow normal distribution. So what I want to say now, u is also going to follow normal distribution. I don't need to be worried about that, because I've been told that the components follow normal. All what I just need to do is, let me find the expected value of u, and let me find the variance of u. Now, expected value of u, okay, is going to be, I want to take the expectation of each of these. A constant is going to come out, it's going to be expected value of y1. And what is the expected value of y1? Mu1. That was why you got this guy. Okay, what about the variance? It's going to be this guy. Do you know that the moment I know this, I will conveniently write, okay, so I'll conveniently write, I'm going to say u follow normal, okay, with the mean, okay, and the variance. Okay, so if I now want to write it out based on what I'm seeing, okay, I'm actually going to say u follow normal. What is the expected value of u that I have? Summation ai mu I start from 1 to n. Okay, then summation, okay, summation ai squared sigma I squared. I start from 1 to n. I'm done. And do you know what? If I now want to write my f of u, for normal, it's super cool. The moment you get the mean and the variance, you can now write the normal density, where you're only going to use stuff like this. You know what I'm going to do now? I'm going to write I'm going to write 1 over square root of 2 pi. After 2 pi, what do you have next? Variance. What is the variance here? The whole of this. Okay, I'm going to write summation a I square sigma I start from 1 to n exponential raised to power minus half summation a I squared sigma I squared. What am I going to have? Then u minus the mean. U minus this ai ui. I start from 1 to n. And here, don't forget to put a squared. Do you know this is the f of u? How do I know f of u? Because I've been told from the beginning that each of the components follow normal. Then if I want to derive the f of u, all what I just need to do is to first, let him get the expected value of u, the variance of u. Then I'm going to write the density how. Okay, I'm going to write the density how. Now, do you know that I can also get the moment generating function for that? If you take a look at what I'm quickly doing here, if this is the moment generating function of a normal for y, high, it could be y1, y2 up to yn, then the moment generating function of a linear combination can be written as that. The one with a constant can be written as that. Now, using this, right now, for the one we did before, we can multiply each. This is the first one. And this is the last one. Then what do you see? Oh my God! Take a look at what I have here. Do you know? Do you know? Do you know if I don't want to waste my time doing that? If I know that this is the F of U, if I want to write the movement generating function for U, I will recall what is the movement generating function for, we derived that before, right? Mu T plus sigma square T square over 2. This is for the individual. What is this? Mean, right? What is this? Variance. You know what I'm going to do? Here, where I have mu, I'm going to plug in this. Where I have sigma square, I'm going to plug in this. That is what they are doing here. Then when you know the components, you'll be fine with the system. Okay. Tomorrow I'm going to release practice question for final. Don't forget the final is written in person in this venue. Okay, make sure you all stay safe and have a lovely day. Bye for now, everyone.